This conference will now be recorded.
Great. Good morning, guys. So yesterday we were discussing about deep dive and fundamentals and what happens under the hood when you train a model. So we are talking about the linear regression process and what exactly happens in and out when you train a model in the linear regression. So yesterday we were talking about the formulas, and today we'll continue uh, how these formulas and the intercept values, and if you talk about x, y, and theta 1, theta 2, and h cap, you need to know what is x, what is y, what is theta 1, what is the theta 2, and what is y cap. So we are in this process of completing that. So let's resume from the point where we left yesterday. Okay, so now what happens here is, yesterday we were talking about the intercept values. If you go back and recollect, we have done the life satisfaction use case. The life satisfaction use case formula is equal to theta 0 plus theta 1 into GDP per capita. Now you may ask, what the hell is theta 0 and what the hell is theta 1? So theta 0 will be the y-intercept. When I say y-intercept, the slope at y. When I say theta 1, that is slope on the upper part of the x, which is called m. So how these theta 0 and theta 1 are importantly contributing for the formula is important to be understood. It's 5 hours. Okay, so now here what happens is, if you ask me a question, Amar, you said something about y-intercept, which is theta of 0. What happens if my y-intercept, basically every time when we start assuming or assigning the values, we start from 0. You always have to start from origin. That is the reason why. What happens if theta of 0 is 0? Theta of 0 is 0 because if y-intercept is 0, then line will pass through the origin 0, 0, comma 0. 0 is on your x-axis, y is on your y-axis. So y equal to mx will pass from 0 if theta of 0 equal to 0. Very important thing to be understood, and you may get this question in the interviews. Why do you think the intercept value theta of 0 is equal to 0? Just say any observations to start from one point, and if it starts from the point 0, then it makes a better estimate to predict the values. That is the reason why theta of 0 will be 0. Okay, now perfect. Let's move on to next slide. Here, next slide, we are talking about correlating the things. Whatever questions you have asked me in the end-to-end machine learning project, all those questions will be answered with a clear explanation in this module. Because when we did linear regression, we didn't know anything about linear regression, but yet we tried to do linear regression, and we understood how the syntaxes can be inherited, how the syntaxes can be used, and how you can train a model, fit a model, check the errors, check the predictions, check the scores, blah blah blah. We have done so many beautiful things. As now we are talking what exactly the model does, how the model performs, how the model is trained, and how the model errors are identified. Okay, now let's go back to the end-to-end project. For example, if you say, if you're building a model for predicting the housing prices using below attributes, you have been given latitude, longitude, inhabitants, and median income. Now, what will be the general equation of linear regression? Guys, there are new terms which comes in your way. One is general equation, one is line of equation, other one is normal equation. General equation is the theta 0 plus theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3 plus theta 4 into x4, like that. Okay. Normal equation is equal to the normalized form of the equation, and line of equation nothing but how the line on the linear regression represents the whole functionality of it. So don't worry, do not get confused, have it clear. The general equation, the normal equation, the line of equation. General equation is the quite generic one. The normal equation is the normalized form. When I say normalized form, it is the biggest formula cut short into the smaller one. And the line of equation is the line that shows the entity relationship of your x and y. When X changes is Y changing. If Y changes, then X changes, like that. So I would like to recollect, I would like to revisit. Don't get confused with line of equation formula, general equation, or normal equation. Okay, I'll explain each and everything so clearly that you will love the subject. Trust me. So till here what's happening is general equation of linear regression. So in the general equation of linear regression, if you were given four important attributes, you need to build a model from that four attributes. In that case, what happens is, let me take a pen here. Theta 0 will be the starting point, theta 1 into longitude, theta 2 into latitude, theta 3 into inhabitants, plus theta 4 into median income. Now you should raise a question. Okay, boss, you have four features and you multiplied your theta of that specific uh, instance. When I said that specific instance, theta 1 is one instance, theta 2 is another instance, theta 3 is another instance, theta 4 is another instance. Theta 1 is multiplied with latitude, theta 2 is multiplied with longitude, sorry, theta 1 is multiplied with longitude, theta, theta 1 is multiplied with longitude, theta 2 is multiplied with latitude, theta 3 is multiplied with inhabitants, theta 4 is multiplied with median income. So now here what happens is, what exactly happens if I have 100 instances? What happens if I have 100 instances? Straight question. When I have 100 instances, theta of 100 will be multiplied with the 100th feature. That is the reason why we keep on saying x of I is the ith future instance value. Hope that is making sense now. I repeat, when you say ith instance or x of I, that's the ith instance future value. Now, what is the future value of third instance? Inhabitants. The future is inhabitants. The value is whatever you get when you multiply theta 3 into inhabitants is the value of third instance. Now let's take what is the value of fourth instance. Theta 4 when multiplied with median income will give you a value that is a fourth instance future value. Now we need to understand what is theta 4. To understand theta 4, you need to understand the intercept value. The intercept value theta of 0 will be equal to 0 because you have to start the observations anything from the starting point of x and y. Okay, now let me now make some more beautiful explanation on theta 0. Theta 0 is called as constant, also called as bias or intercept term. Remember this word, bias term or intercept term. This is so important that simple thing can mess up the whole predictions. If you show very less love to this constant term, it doesn't care you. If you love it so much, it 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 loves you more than what you do. That's the importance of this bias term or intercept term. Remember these terms, these are very important. Now, theta 0 will be your intercept term or a constant term. Perfect. Theta 1 will be the weight of longitude feature. I know. Now you are understanding what is the feature's weight. Longitude is one feature and theta 1 is the weight of the longitude. Perfect. Now, theta 2 is the latitude feature. So latitude is one other feature and theta 2 is the weight of that feature. Now, theta 3 inhabitants. Theta 3 is the weight of the inhabitants feature. So theta 3 is one feature and theta 3 is the weight of inhabitants feature. Now, theta 4 into median income. Here what happens is theta 4 is the weight of the median income feature. Now, let me quickly show you something. In this slide, you understood important things like weights. You understood the important things like future values, and you understood the important term of bias or intercept term. Perfect. Now let me quickly show you something. Let me erase all the drawings. Let me go back to the pointer. Now, what is linear regression? A linear model making a prediction by simply computing the sum of the input features. What is the sum of the input features? Sum of the input features is latitude, longitude, and the other two, plus a constant bias term. The constant bias term is nothing but theta of 0. Now it is making sense to everyone, right? Who has joined? Kavi. Perfect. Thank you. Thanks, Kavi.
Yes, sir. Good morning.
So, good morning. Good morning. Yeah. So this is what it is. So you get the linear regression formula understood clearly till this point now. Okay. So you understood about constant term. You got the weights and you got the features. Perfect. Now, what is a general equation? Here we are talking about general equation. What is the formula of general equation? General equation formula is nothing but y of hat or y of cap will be the predictions. Theta 0 will be the intercept value. Theta 1 will be your model parameter, and x1, x2 will be the future values. Okay, now let me read out this carefully for you so you'll understand what I'm talking about. Y is the predicted value. This is your prediction. Super. N is the number of futures. Now, if you have 100 futures, you'll have intercept value into that futures multiplication. X of I is ith future value. X of I is ith future value means theta 1 into longitude, theta 2 into latitude. Here, theta 1 is longitude's future value, okay, or longitude's value. See guys, theta 1 into x1. So let's say this is longitude and this is latitude. Like this, you'll have x of 3, x of 4, x of 5, x of 6, x of 6, x of 7, like that, x of infinity. In that terms, x of I is the ith future value. Ith future value is nothing but this one, first value, second value. Like that, we'll have I, for example, like that. Now, theta of 0 is constant. This is also called bias or intercept term. You need to really understand this very well. You need to really understand this very well, because this is very important. If this is misunderstood, the whole project goes for stake. Like that, you have theta of j. Okay, so theta of 0 is constant. Perfect. Theta of j is jth model parameter, including the bias term theta of 0 and the future weights theta 1, theta 2 to theta n. Perfect. That's nice. Now you understood, you related what you learned, you related what you understood carefully. I repeat, do not get confused within general equation, line of equation, and normal equation. Basically, they all does the same work, but one is expanded form, other is minimized form, and other one is explained in the form of a graphical form. That's how things works. Okay, perfect. Now, let me move on to next bit. I'll remove all the drawings. Can you see the drawings, Kavi?
Yes, sir. Yes.
Erase all the drawings. Go back to the pointer. Perfect. This is making sense now. Yeah. Here. What is bias term and why is bias term so important? I was talking about theta 0 so great, and I also asked you to understand it very carefully, right? Now let's jump into the bias term. What is bias term? Why is it so important? Because without bias term, our solution may go through the origin. Because if bias term starts from 0, the assumption is starting from this point. This is 0 of x and 0 of y. That's what I have shown in the diagram. Now, adding a bias weight allows the algorithm to easily fit the data that does not pass through the origin. Now, in just before slide I showed you, if theta is equal to 0, then what happens? Your assumptions start from this point. Now, take this point here. If you are adding a bias weight, means let's say theta equal to 1, or let's say theta is equal to 2, or let's say theta is equal to 3, let's say theta equal to 4, like that. Whatever this happens, this will easily fit the data and does not pass through the origin. That is the important of the intercept value. Perfect. Now, let's say if all the features are 0. When I say all the features are 0, you talked about x1 like longitude, you have x2 like latitude, and you have inhabitants like x3, and you have a median income like x4. Okay, these are the 4 important input features that were given to you. Now, if all the future, guys, just understand this is only a future, not a future value. If I say x of I, then that is ith future value. When I say x of 1, that is first features value. When I say x of 2, that is second feature value. But future is longitude here, latitude here, inhabitants here, and median income here, as I shown you the previous slide. Perfect. So here what happens is, if all the features are 0, then predicted value should also be 0, obviously. Now, however, that may not be the answer that training data suggests. Okay, so bias term will always be constant and does not depend on any feature. Okay, always remember, bias term is a constant term and does not depend upon any feature. But bias term will have to bias term is very important to make any predictions or any assumptions before making the predictions. This is the importance of the bias term. Okay, now let me jump to the next slide to make this more clear for you. Erase all the drawings, go back to the pointer. Next slide is here. Now I'm talking about the general equation here. So guys, let's remember the other day we have stopped here. If y-intercept is 0, then line will pass through the origin, x-axis 0, y-axis 0. Here we are talking about linear regression under the hood. Here I explained you what is a constant term, what is a longitude, what is a latitude. When I say longitude, longitude is one of the feature, latitude is one of the feature, inhabitants is one of the feature, median income is one of the feature. Okay, and the train model formula for linear regression will be theta of 0 plus theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3. So x is longitude, latitude, and inhabitants. Theta 0 is equal to constant. Now this constant is nothing but a bias or intercept term. The reason why this is so important is, if your intercept is 0, then the whole things will change to 0. So you need to add weights to your bias term, so that will allow the algorithm to easily fit the data that does not pass to the origin. Okay. Now, for any reason, if you say the features are 0, all the values should be 0. So the bias term is constant, that does not depend upon any features. Perfect. Now we are talking about line of equation. This line of equation is nothing but, let me show you this one. Let me take a pen here. This one, line of equation is this one. You need to understand how this line is built, what happens under this line, and how you need to, what you can do so you will get the best line. Okay, very important, guys. Now that is all the drawings. Perfect. That's good. That's definitely good. Now let me go back and go to the pointer. We are here. Okay, now, so you understood theta in here. in here, guys, try to understand something. There is a difference. Theta of 0 is a constant or bias term. Okay, theta of 0 here, but theta of 1 is not constant term or bias term. Okay, I want to explain you that now. Okay, now here what happens is we are talking about a new term called theta. Theta 1 is a bias term, a constant term. Register that and park it in your mind. Theta of 0 is bias term or intercept term. Just remember that and park it away. Now come with fresh mind. When talking about the general equation of linear regression vector form, okay, you need to understand few things. Theta is the model's parameter vector. Theta of 1 will be your bias or intercept term. What is theta? Now, understand this formula, guys. Don't understand this formula. Look at this formula. What is theta of t first? Okay. If you know theta, I can say theta of t is nothing but transpose of theta. Transpose of theta means rows are converted into columns, columns are converted to rows. That's what it is. Simple as it is. Now, you need to understand what is the h of theta. Okay. You need to understand what is x. Okay. Simple. Y of cap is the predictions. Y of cap is equal to h of theta of x. When I say h of theta of x, that is nothing but theta transpose dot x. Okay, that's what it is. Now, let me explain you more clearly on how things will work here. Now, theta is the model's parameter vector. Parameter vector is nothing but anything that is put in the form of a matrix. The features is called as a parameter vector. Okay. Now, theta of t is the transpose of theta, means a row vector instead of a column vector. So if I have columns like this, 4 columns, that 4 columns will be converted into 4 rows. Here I have 1 row and 4 columns. Now what happens? I have 4 rows and 1 column. That is what it is. Now here x is the instance future vector. Guys, just go back. Earlier, what did I say? X of I is the value of x future. Now, here x is the instance future vector, okay, containing x of 0 to x of n. Okay. Now, earlier what I told you is y is equal to theta of 0 plus theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3, like that, theta n into xn. Now, x, that theta 1 x1 theta 2 x2 theta 3 x3 theta n xn is simply represented in the form of an x, that is instance future vector, and this instance future vector will always contain x of 0 to x of n. Amazing. With x of 0 always equal to 1. Perfect. Now, for example, this is how it's look like. Your x will look like this. X equal to 1 comma latitude longitude, like that. Okay, because this is now a vector. You understand what I'm saying? This is one row. Okay. Now, theta t dot x is the dot product of theta t and x. So, very simple, boss. Very simple. First, you understood theta is your model's parameter vector. Amazing, zing zing, superb. And then you have a bias term theta and a future weights given is theta 1 to theta n. This also you are aware of. Perfect. And then theta of t is nothing but transpose of theta, which is nothing but the row vector instead of column vector. And x is the instance future vector, which can be understood as x1 into theta 1 plus x2 into theta 2, where x is having all the values of x of 0 to x of n. Now, when I do theta t dot x, the theta value will be transposed and it will be multiplied with x. When I say multiplied with x, x will be the x of 0 to x of n, with x of 0 starting always equal to 1. Now, here, h of theta is an hypothesis function. Hypothesis function means if you do this, this will happen. If you do it this way, things will fit this way. If you don't do it this way, you'll have to do this one. That is hypothesis function. So this hypothesis function will keep changing. But always remember, x of 0 will always be starting from 1. When I say x of 0, that is part of x, because x is nothing but instance future vector. Vector means you have a lot of values and all the values are represented in one matrix, is called as a vector. Now, h of theta is hypothesis function using the model parameter theta. Now, h of theta fits the model. Okay, this is fitting the model perfectly. When it fits the model, it properly calculates the weights. When I say weights again, go back to linear regression formula I just explained. What did I say? Linear regression is the sum of the input weights plus a bias term. Let me go back there. Give me 1 second. I'll take a pointer now. A linear model makes a prediction by simply computing the weighted sum of the input features. When I say weighted sum of the input features, if you see here, h theta is calculating the weights. Okay, now this h theta fits the model. Okay, and it will also calculate the weights. When I say weight, what is the weight of the latitude, what is the weight of the longitude, like that. Now we have our linear regression model equation understood perfectly, but how do we train it? That is the important part of it. Okay, so all this while we are talking about what is linear regression, how linear regression works, what is the formula of linear regression, all these things. Now you understood everything about linear regression perfectly, and you need to just get a heads around on how do you use linear regression for your process and how do you train it. That is the important part of it. So let's do a quick recap. Till this point we understood about the normal equation, the general equation, okay, line of graph equation. Okay, I think the line of graph is yet to come. Yes, it's here. Perfect, that's fine, no problem. So you understood about general equation in your linear regression, and you understood about bias term and intercept terms, and you also understood the vector form of the general equation. Okay, now here, as you have understood everything perfectly, now let's go and train a model using linear regression. How do you train it? That's what the important business part here is. Now, training a model means setting its parameters. How are the parameters set? Okay, when you are setting these parameters, the model best fits the training set. When I say setting the parameters, I have to take the best parameter such that the best parameter fits the training set perfectly. Perfect. For this purpose, we first need a measure of how well or how poorly the model fits the training data. This is where your errors comes into picture. Understand the flow. If you understand the flow, automatically you will love the subject and you love the code approach process. So whenever you're training a model, you're setting its parameters. When you are setting its parameters, that means you are trying to do a best fit for the training set. When can you say it is a best fit? Because you need to first understand if the model is doing good or bad with the initial inputs you have given. Right? For example, boss, I'm giving you some money to get me stuff. If I give you enough money, you'll go and buy the product and give it to me. And if I give you less money, you'll go to the shop and come back to me telling You gave me £5 and asked me to get a product, but unfortunately the product price is £7 and I can't do anything. What will I do again? I'll give you another £2 and I'll ask you to go back, go to the shop and get me the product. So this time what happens? As I've given you the enough money, you will use that money and get me the product. That's what the linear regressions poorly or well a model fitting the training data. Okay, now let's go back that when we have seen the end-to-end project. In the end-to-end project, we understood about RMSE, which is called as root mean square error. And we also understood about mean square error. Perfect. Now, here what I'm trying to tell you is mean square error for training the model in this section. Okay, we are going to use MSE. Okay, now you may ask me, why the hell are you using MSE? Why not RMSE? Very simple. The reason is it is simpler to minimize a mean square error rather than root mean square error. Okay, so for you to understand between MSE and RMSE, I'll say two things. I have number 8. What is 8? 2 power 3. Okay, now this is MSE and that is RMSE. 2 into 2, 4. That is square of 2. And again taken 2 times is nothing but root mean square error. The other way of telling it is the distance from this point and distance to this point is same. From here and from here, the distance is same. When I say distance from this point to this point is same, that is called Euclidean distance. There's a formula called Euclidean formula, which let's not go into that, but the fundamentals from where MSE and RMSE came is this one. Okay, so simply as a machine learning engineer, what I want you to understand and remember is whenever you train model, you need to fit the best parameters. To do the best parameters, you need to understand if the model is doing good or bad with the given parameters. To understand if it is doing good or bad, you need to understand the errors. How do you predict the errors? Using MSE or RMSE. MSE is mean square error and RMSE is root mean square error. Super. Now, why are we using MSE here? We are using MSE because it is simpler to minimize an MSE than an RMSE. Perfect. The function which minimizes MSE also minimizes its square root, so it doesn't matter to use MSE or RMSE. This is very important. If you are dealing with a proper function that can minimize the mean square error, then it will also have the capability to minimize the root mean square error also. So don't worry about it. A function which minimizes MSE will also minimize its square root. So it doesn't matter to use MSE or RMSE. Perfect. This is what it is. In this, we jumped into training the model parameters. Okay. Erase all the drawings. Go back to the pointer. Okay. Now, see here. Here, what happens is, try to understand, look at the diagram carefully. This is my housing area on x-axis. This is my housing value on y-axis. Now, let's say we want to predict a house value based on the house area in square feet. Perfect. We will use univariate linear regression because there's only one feature called housing area. Now, house value versus house area actual data. So this is the line of graph, I would say. Okay. Now, what is this saying and what is this saying? You cannot understand anything, or you should at least think like this, right? I'm coming there. Bear with me. You understand what I'm talking about. Don't worry. With this one, we are going to make our fundamental building blocks so strong. Okay. Like this. Okay. Now, let me erase all the drawings now. Just look at the diagram. So this will be the line of equation. On top you have 1, on below you have 3, or this will be between the top and bottom. So you have 3 here. Okay. Erase all the drawings. Go back to the pointer. Okay. So this is the way how it looks. Now, let me explain you the proper diagram here. Look at this. This diagram will give you the clear explanation now. Okay. Now, okay, boss, understand? This is your theta 0 plus theta 1 into your housing area. Okay. This is the model trying to fit to the training data, and it gives the output like this. Very good. I understand. Now, take this one to the here. Now, this is y1 of cap and this one is y. Now, y1 is the actual value, y1 of I is a predicted value. Okay, so I got one dot here and that dot is this one. Perfect. This is the actual value, so I say actual value. Okay, now try to understand something. What is the line of graph saying? Okay, so basically it started from this point. Focus guys, focus. I'm not touching this because this will be used as reference for you. Today you understand everything about the, trust me, we have prepared the slides so good, and I have also cross-referenced the book so that I can explain you pretty well. Okay. Kavi, I need your honest feedback on this one. I know the state of mind you guys were in all these days, but today, looking at this diagram and looking at this explanation, you should be in a position to really go back and relate things perfectly. Okay. Now,
Yeah. So very clear. It's a predicted value, but it's like a range. Am I correct?
exactly.
Y1 and Y1 cap is like between the range.
Yeah. Earlier, when we were doing the machine learning end-to-end project, you are not here. Nitvesh has got so many questions, Minu has got so many questions, Kichu has got so many questions. Okay, this was not like that because we
Okay.
are deep diving and trying to understand each and every part of it. When I say each and every point of it, what is h of theta, what is x, what is y cap, what is intercept value, what is future value, what is vector, and all these things. Okay. So now, okay, so now let me erase everything, guys. Now you'll understand why the hell are we using normal equation or general equation or the line of graph equation. This is not line of graph equation. This is a general linear regression. This is the line of graph equation. Okay. Now guys, understand carefully. If I don't know this distance, can I get y and y cap? Kavi, I can't get it, right? So this is nothing but distance from there to distance from here, Euclidean distance I was telling. Don't worry about the term Euclidean distance, just understand why, how y and y cap are there. Now this is the actual value, but the predicted value is falling here. What about the distance between this one? Let's put a question mark. Okay, this is a fitting a line. Now let's talk about errors in the predictions. Errors in prediction is nothing but y1 cap minus y1. So this value minus this value is nothing but the distance covered between this. Now, if you don't have this line, will you be able to say the distance between actual and predicted? Tell me something. Kavi?
No, no.
You cannot say that, right?
Yeah, we can.
That is the importance of the linear regression line of graph. Okay? Now, as this line came into picture, you understood the differences and the distance between the actual value, predicted value. This is MSE. MSE means, boss, my actual value is y1 and my predicted value is y1 of cap. Now, let's come to here. Here, you are simply squaring your MSE. MSE is mean square error and RMSE is root mean square error. So if you do MSE mean square error, simply you are squaring the actual value minus the predicted value. Okay, again this is the same thing. Hope you got a clear sense of why we are doing it, what we are doing it. If you have any questions, please feel free to ask me right now. Anyone? Any questions? Kavi, is everything clear?
Yes, I'm arresting.
Perfect. I appreciate that. L is on
Yeah.
drawing. Now, let me go back to the pointer. Here. Now, so what happens when you're training a model? When you're training a model, we have to find the value of theta. Again, theta of 0 is different, theta of 1 is different, theta is different. Theta is a model's parameter vector. Or I can say theta is weight, future value weight. Now, you need to find this one first priority. You need to find the value of theta, that is minimizing the root mean or mean square error. Okay, and understand how the mean square error is performing on that specific theta. Now, when I say theta is future value weights, hope you understood. We talked about theta 1 into x1, right? Now, x1 is longitude. The value of longitude is nothing but future value. The future weight means theta 1 multiplied with x1. Like that, you get theta 1 or theta 0 plus theta 1 into x1 plus theta 2 into x2, like that. That understanding the term is very, very, very important. If you don't understand the term, you confuse yourself. And when you confuse yourself, your fundamental building blocks are not strong. And someday or the other, your house will fall when a cyclone comes. Do not wait for the cyclone. Build your fundamentals strong, so nobody will question you. At points where you are being questioned, you will be in a position to give a fitting answer. The amount of time you're investing right now for machine learning and data science is the best investment you're making. Trust me. Already you're waking up by 5 a.m. every morning. You're investing a very quality time and expect the returns properly. Okay, perfect. Now, when you're training a model, you need to find the value of theta. Yes, I know that. Like that, you also need to minimize the MSE. I know that. And now let's understand the MSE more properly. Now, MSE of linear regression hypothesis H theta on a training set X is calculated using the below equation. The equation is here. Okay. Now, X of I is the vector of all future values, excluding the label on ith instance of dataset. We know this one because we have been talking. Okay. I is the label. When I say I is the label, the desired output. Okay. This is I. Y of I. Now, you know theta of t, we discussed earlier. Okay, you know x, and now we're talking about x of I. Okay, and this is the formula. You don't have to worry anything about this formula. I also clearly told you what happens if a letter is in bold and capital letter. I also told you what happens if the letter is small and bold. Okay, these are very important, you need to understand. Let me quickly recap that also for you, because that makes sense. Let me go back to pointer. See, look at this, my dear Fazio. Look at this. If a letter is bold font, lowercase, that is a vector. Again, guys, if a letter is given with bold letter lowercase, that is a vector. What is a vector is nothing but all the input features represented in the matrix form is called a vector. Superb. Like that, you have an uppercase bold font such as matrices. Okay. Matrix is nothing but a matrix representation form. Now, apply this logic over the formula. Get things registered right now. If you have a small x which is bold, that is a vector. If you have a small x that is in bold, that is called a vector. If you have a uppercase bold, that is an matrices. Hope you understood the difference between uppercase bold and lowercase bold. Lowercase bold is a vector and uppercase bold is a matrices. Tomorrow I'll ask you this question again, Kavi.
Yeah,
Okay.
sure. Yesterday's
So
slide itself.
did you finish yesterday's class?
Yeah. I finished.
Perfect. That's
That's
good.
why I'm getting some idea.
Perfect. That's good. See, this is the difference, man. If you have the flow, you love the subject. For any reason, if you missed one class and try to understand the second class, you lose the interest and you won't get the things on top of your head, and simply you'll just attend the class for sake of attending it, which won't give you any benefits. Okay.
Yeah.
There's all the drawings. There's all the drawings. Now go back to the pointer. Okay. Now this is also done. We are here. What is uppercase X? Kavi, what is uppercase X? What is this uppercase X?
Matrix.
What is the lowercase x?
Vector.
Vector. Perfect. So now we understood the concept clearly. So
Yeah.
now see here, x of I is a vector. Okay. And y is the prediction. Okay. And this uppercase X is the matrices. H of theta is the hypothesis function. I told you about this very clearly. And if you want to just understand it once again or go back and look once again, go ahead. Here I explained you about h of theta. Look here, h of theta is the hypothesis function. This function will have model parameters theta and fits the models and calculate the weights. Okay, that's what it is. Superb. That's nice. Now you got this one, you got this one, you got this one. Okay, you also understood this one. Now let's take another example and try to read that example with the practicals. Okay, now here what happens is, for example, if the first district in the data set is located at longitude of 118, let me take a pen here. See boss, what is smaller case x? Kavi,
Vector.
what is vector? This is the proper vector. Okay, now this is for one district.
Yeah.
If the first district means this is number first. So this is the vector value of first district. Okay, or a vector is nothing but the future values. 118 is one feature, latitude is one feature, inhabitants is one feature, medians is one feature. Okay, and prediction is here. Now, simply, though I'm telling this as a vector, these are the input future values that are represented in a vector, and this is my prediction. Did you get the idea of how things work now?
Yes, yes.
You got it right?
Yeah, yeah, got
Perfect. That's good. I appreciate that. Very nice. Okay. Erase all the drawings. Go back to the pointer. Now, what is a key thought? One important thing you must be very much aware is when you are training the models, we just have to find the theta. Theta means model parameters, future weights. Future weights means what is the best parameter that gives the best features. When I say best features, best predictions. Okay, that's very important. Now, if you have the best model, that best model will minimize the root mean square error. When you get the minimum root mean square error, that means you have less errors. When you say less errors, that will give you the best predictions. That is what it is. Okay. Now, minimizing the MSC. Again, let's focus carefully, guys. This is a very important slide because if you understand this slide, we are almost done with the MSC part of it. Okay. Understand carefully. Now, let's understand how training a linear regression model is done internally. Okay, there are two approaches to train the linear regression model. The first one is the closed form equation, and the second one is gradient descent iterative optimization approach. Okay, now the normal equation is nothing but the closed equation. The normal equation is nothing but the mathematical equation which gives the results directly. That is the reason why it is called a closed form. Okay, so guys, very simple. Look at the diagrams. This is theta of cap, theta of cap. Okay, this is your X training data set. This is your X training data set. Now, value of theta that minimizes the cost function is nothing but the theta you need to find. Super. What is y here? Y is the predictions. So y is a vector of the target having y of I to y of m. Again, y is in small case and it is in bold. What is it? Vector. What is x? That is matrix. Okay. Now, when you're talking about MSc, just remember two things. The first thing is MSc is nothing but the errors that comes when you train a model. In linear regression, you can train a model in two approaches. The first approach is the normal approach, which is nothing but the normal equation. In this normal equation, that is just nothing a mathematical formula that gives the results directly. And the next one is gradient descent approach, which is the iterative optimization approach. So when you're talking about the normal equation, you need to understand x, y, z of normal equation. When you're talking about gradient descent, you need to understand the x, y, z of gradient descent. Okay, now let's jump into that one. Hope you are understanding that I'm trying to connect each and every dot that came in our first use case. Now, here is all the drawings. Go to the pointer. Okay, now let's do some hands-on to understand the errors and predictions. Okay, this is simply straightforward, boss. Okay, if you want, you can copy and paste it, and I also already done it. I'll show you right now. So first, first one, what are we doing here? We are first generating to some linear looking data. So I'll use numpy as np and uniformly distribute the array with dimensions of 100, 1. So I'll use numpy random.rand 100, 1. So this array will be distributed. Now, normally distributed array with noise. With noise is nothing but I am giving y equal to 4 plus 3 into x. Again, what is this y and what is this x? Just go add and understand y is equal to m plus xc. You remember the formula, right? I'll show you that.
constant value.
Yeah. So we are talking about that one, right? So now, if you see this example on my right side, what is this one? Theta 0. What is this one? Theta 1. This is the Gaussian noise. Gaussian noise is nothing but you are generating some random numbers every time. Whenever the code is run, if I give 1 to 100 in the next time, I'll give 99, 98, 97 to 100 one time, and one time I may give 55, 60, 19, 91 like that. Okay, that's a random noise. Try to run this code on your machine. You'll understand what I'm trying to say, which I've already tested for you. Let me show you. Pointer. Guys, these are all very important topics. Whatever the questions that have really bothered you last time will be clearly answered here now. So import numpy as np, x equal to 2 into np, which is nothing but I'm trying to do some random numbers 101, and then I implemented the y equal to mx plus c, the constant or bias term formula here. Okay, now again I'm trying to plot it. When I'm trying to plot, I implemented the matplotlib. Simple. Here x label is, don't worry about this x underscore $1, which is nothing but you're telling your x-axis, and like that you are also telling about your y-axis. Okay, now plot axis 0 to 2 on x-axis, 0 to 15 on y-axis. When I say 0 to 2, 2.5, starting value is 2, ending value is, starting value is 0, end value is 2. When I say 0 comma 15, starting value is 0, ending value is 15. Okay, again this $x minus $1 is nothing but the font size on your x-axis is 18, and like this you are talking about y label on y-axis. Okay, now do you see this one? You got a line here, right? So in this line you got a value here, but it should be here like this. Again, you got a value here. I'm just taking some random numbers to show you. This will help you to represent what is actually happening and how things are working under the hood. Okay, now erase all the drawings, go back to the pointer. I want you to run this on your laptop so you understand what I'm talking about. Okay, so now x and y definitely have a linear relationship by looking at the diagram, because if x is going down, y is going down. If x is going up, y is also going up. Okay, this is how you can get some hands-on while understanding the concepts and relating the concept to your practical thing. Next one, normal equation under the hood. Let's also test this one. I'll stop it now. We'll resume it tomorrow. We have covered very nice topics today, and people who have not attended the morning session, please try to complete this by today, because this Sunday workshop is very important. Whatever the concepts you have trying to learn now will be related when we do the practicals part of it. Okay, practicals, let's have the workshop at Sunday, and we'll catch up by 9 a.m. I'll be there early, and I'll set up everything ready for you. I have the instructions also ready, and we can start working on the face recognition and emotions of the face. Okay, thank you, Kavi. Thank you for joining me this morning. I hope you're enjoying the sessions, and it's just a few more days. I think we have 28 days more. For yesterday's 30 days, today's 29 days left. Okay, by June 9th, we should be able to deliver everything perfectly, and I'll target to make sure one or two guys goes into the jobs. Okay.
Okay.
Thanks, Kavi. Have a great day. Enjoy your work.
Yeah, thanks.
Thanks. Bye.